Okay, so we were talking about polygons. Let's discuss a particular type, quadrilaterals, where we have four sides. It could be a square, parallelogram, rhombus, any four-sided polygon. So let's draw it. Okay. Now let's say this is 1, this is 2, 3, and 4. So we have four angles here. The thing which you need to understand is that sum of 1, 2, 3, 4 is 360 degrees. Okay, that's it. This is the only thing I wanted to mention here, that the sum of angles inside a quadrilateral is 360 degrees. Okay, how? I'll tell that through a formula. Okay. So obviously we cannot learn this for every figure, for every type of polygon. We need to have something in general. So sum of interior angles, right? So the sum is 180 into x minus 2, with x being the number of sides of a polygon. Okay, so we have just discussed and talked about the quadrilateral. So we had four sides. If I use this formula for x equals 4, I will get 360. Right? So you don't have to learn or remember or memorize extra things when you have this formula. Okay, this is very important. Okay, just keep this formula in mind. Okay, so this is what we have for the interior angles, and for exterior angles it says sum of exterior angles of any polygon is 360 degrees. Okay, you should be very clear with this, that sum of exterior angles of any polygon, even if it's a triangle, square, rectangle, rhombus, hexagon, pentagon, the sum of exterior angles would be 360, and the sum of interior angles can be calculated this way. Okay, so let's talk about what exactly exterior angles look like. We have discussed that in case of a triangle, but I have a practice question here, so we can discuss it here as well. Okay, so is it clear?
Yes, ma'am.
Okay. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay. So what is the sum of interior angles in this case? It would be 180 into x minus 2. What is x? Ishu, what is x in this case?
8.
Very good. So it's 8 minus 2, and this would be 1080 degrees. Okay. And if I talk about exterior angles, my sum would be 360, right? The sum. But what are the exterior angles? Let's discuss that. Just continue every side and you'll get a better idea of what exterior angles are. Okay, I'll not do it for every side, but this, and these are the exterior angles, okay? We did discuss this in case of a triangle as well. Okay. So this angle, then this angle, and this angle. These three angles are exterior angles, okay? And we said that if this is 1 and this is 2 and this is A, so A would be 1 plus 2, right? We know this. So we have discussed what exterior angles are in case of a triangle, in case of this figure, octagon. Okay, is it clear? Is it clear?
Yes, ma'am.
Okay. Let's talk about similar polygons now. Okay. And then this is the side. And finally, we have this. Okay, so this is a polygon and I'll draw a similar polygon. Next to it. So when I say similar, we have already discussed a question of this type. When it's similar, the angle is same, but the sides are different, okay? Okay. So here we have two similar polygons. This is 135. This side is 75. Here we have 60. So what would be this side? Please find this side and tell me. Find the side and tell me, okay? I'm labeling the rest of the diagram.
Thank you.
And Ishu, what about you?
Ma'am, I don't understand what did you tell us to figure out.
Sorry?
I didn't understand what you wanted us to figure out.
Okay, I want you to find this angle, okay? This angle.
It's 90.
Very good, okay. So we are basically discussing similar polygons, and the thing which we need to understand here is that it is similar because every angle is same, but the sides is different, okay? We need to see the ratios here. So let's say if this is 20 and this is 10, so it is basically 2:1. If this is 18 and this is 9, this is 2:1. And you'll just see why are we discussing this. Okay, we have already discussed a question, a past paper question, but for the sake of completeness, I'll do a question and then you'll get a better idea. Okay, so okay, so this is so here we have two similar polygons. This side is 30, this side is 12, this side is 5, and this side is D. So I want you guys to tell me the sum of interior angles in this case and find D. Okay, we have discussed this already. Question part 1. Sum of interior angles and D side. Okay.
Okay, ma'am. The interior angles, the sum is 720.
Very good.
And D is 2.
And D is 2.
Yeah.
Okay, and Zahib, are you done?
Yeah, I'm getting the same answer.
Okay, very good, perfect. That is correct. Okay. Right, so I will not do it then. Okay. Okay, so we need to know a few things about parallelograms. So it is basically a quadrilateral with two pairs of parallel sides. So this is first pair, and I'll connect the first pair by joining another pair of parallel lines. Okay, so this is how a parallelogram looks like. All right, so this is A, B, C, and D. Okay. So first thing is that AB is parallel to BC and AD is parallel to BC. Okay. Then we need to know that this angle and this angle, they are equal. Okay. So MA is equal to this, right? Okay. And similarly, so these two angles are equal, right? Okay. Then the other thing, this is the first point, this is the second point, and the third point is consecutive angles are supplementary. By this I mean that A plus B, their sum would be 180 because A and B are together. The next angle after A is B, and it works this way as well. Okay, is it clear?
Yes,
Yes,
ma'am.
ma'am.
Perfect. Okay, so these things are important.
Ma'am, I need to note this down.
Okay, yes, you can take your time.
Okay, you can move forward.
Okay. Okay, and again, this would be 360. This is basically coming from the same formula we use for interior angles, but parallelogram is a very popular quadrilateral, so every time you cannot use that formula, you should know this for this, right? For this for any quadrilateral, it's 60 degrees. Okay. All right, we are done with this. Let's talk about special type of parallelograms. So if it is a simple rectangle, this is the first case. Then we'll talk about a rhombus. Okay. Then we have square. Right. Okay. Now this is a simple rectangle. This is a square. And this is a rhombus, right? In this case, we know that this side is equal to this, and this side is equal to this. In square, all sides are equal. And in a rhombus, every side is equal as well. Okay. All the rules hold for all the parallelogram rules hold for the rectangle, rhombus, and square as well. That sum of these two would be 180, and this would be 90. all the sides would be 90 in this case. But here again, it's not necessarily 90. Some would be 360 in total of all the angles, and for the individual ones it would be 180. So this is AB, MA plus MB would be 180, okay. And yeah, okay. So is it clear?
Yes, ma'am.
Okay. Let's talk about diagonals in a rectangle. Okay, so this is basically what a diagonal is. And let's say this is A, B, C, D. Then we have basically triangle ADC equals ABC, right? Because these two sides are same and this is being shared, their area would be same. So we get two triangles. And if I draw another diagonal this way, let's say this is E. You should know that AE is equal to CE because this would be the midpoint. Similarly, DE would be equal to BE. And in case of a rectangle only, okay, the length of diagonals is same. This is equal to this. These lengths are same, okay? All right. Now, if I talk about the same thing, but for rhombus particularly, this is one side, this is the other side. Rhombus is basically a parallelogram with equal sides. And now if I draw the diagonals, so the new thing here is that this is going to be a 90 degrees angle for rhombus, right? Okay, and if this is A, B, C, D, you should know that AC is perpendicular to DB. This is AC, this is DB, and they are perpendicular. This is why we're getting the 90 degrees angle, okay? Is it clear?
Yes, ma'am.
Okay, perfect. So then we have a question. If this is a square, A, B, C, and D. This angle is A, this angle is C, and this angle is B. So I want you to tell me which of these statements is correct for the square. So we have three statements. Statement 1 says A equals B. Second statement says AC is equal to BD, and then the third one says B equals C. Okay, please tell me. Okay, take your time and tell me.
Ma'am, I think they're all correct.
They are all correct. And what about you, Zahir?
Yeah, they're all correct.
Very good, excellent. Perfect. Okay. So I don't need to explain this. Okay. Now we will discuss solid figures, perimeters, and area. Okay. All right. So let's talk about the very first thing, perimeter, right? So a perimeter basically is, if this is a square, I'll sum up every side to get the perimeter, right? So the perimeter of an object is the sum of all of its sides. So the perimeter would be 13 plus 13 plus 5 plus 5, and that is 36. Okay, this was a very basic example. If I talk about area, area would be this part. So area would be length into width. That is 13 into 5, right? So we know these things for such basic figures. And for the complicated ones, they have given a data booklet just like A levels. So you will have all the formulas with you, right? I'll share the formula list on WhatsApp, and then we'll solve questions together, okay? By using these formulas directly. Okay, just give me a minute. I'll share the list which is given. Just check that. Did you get it?
Yes.
Okay. So let's try out the questions directly. The height of a triangular fence is 3 meters less than its base the base of the fence is 7 meters. What is the area of the fence in square meters? Okay, so please do it and tell me the answer. Are you done?
$14.
Okay, Anishal, what about you?
14. 14.
Very good. Okay, perfect. So this was a very, very easy question. All right. I have a question. So a circular cylinder has a radius of 3 and a height of 5. Stewart wants to build a rectangular solid with a volume as close as possible to cylinder. Okay. So then they have given a few dimensions of the rectangular solid. Yeah. Okay, so this is the question. The question is basically a circular cylinder has a radius of 3 and a height of 5. Miss Stewart wants to build a rectangular solid with a volume as close as possible to the cylinder, okay? So we simply need to find the volume of cylinder first, right? So volume of cylinder is pi r square h. This is the formula. So it's pi, r is 3 and h is 5. This would be 45 pi. Okay. Right?
Yes, ma'am.
Okay. Right. Let's hold things till here. And now we need to choose a rectangular solid which would get a volume closer to 45 pi, okay, whose volume is approximately 45 pi, okay. So this would be 9 into 5. Now 9 into 5 is 45 itself. This is going to be 75. C would be 90. And this is going to be 15 into 9. That is 135. Okay. Now, since it is an approximation, we can take pi equal to 3, right? It is an approximation. So 145 into 3 would be 135. Even if you don't consider this approximation, if you take it as pi directly, you would get 141. But if you're getting this question in the no non-calculator part, and you have been told that you need to, this is basically an approximation because of this phrase, okay, as close as possible to. This is what an approximation is. Okay, the meeting is going to end soon. All right, so yeah. Okay, is it clear?
Yes, ma'am.
Okay, so the meeting is going to end. Okay, let's wait. So I'll end this meeting and share the link, okay?